Oh yeah.
Hi guys. So, first of all, as you may have noticed, I am being recorded again. So everybody say hi to the camera. You guys sound enthusiastic. Jamar, lose the negative thing. Okay, so anyway, as you guys know, senior trip, which means that it's just us five. So most of us are going to be gone today, but we're going to learn new material anyway, because I need to record something. So, up to this point, we've talked about calculating integrals, and yesterday we looked at the beginnings of how to apply integrals. We looked at how to use integrals to represent net change. Today we're going to be talking about a more concrete use of integrals. Today we're going to be using integrals to find the area between two curves. So go ahead and get out your notes and copy down the title and objective of today's lesson. Okay. Keep the phone away. Okay, so finding the area of shapes is something that has a lot of real-world applications. It's used very frequently in science and engineering, and it's also used in fields like art or construction. So for example, if I know that one can of paint can cover 50 square feet, then how many cans of paint would I need to paint a shape that maybe looks like this? What if it's an archway? How can I find out how many cans of paint I need to cover a shape like this? Finding areas is also very important in science and physics. A good example in physics and engineering is for a falling object. If I have an object falling through the air, how fast is it going to fall? What is its terminal velocity going to be? In order to find that number, we have to know what its cross-sectional area is. So, for example, let's say a space capsule. During reentry, how can I find out what its terminal velocity is? How can I find out how much it's going to slow down by? That's important because in slowing down, all that energy that it has from orbit has to be shed as heat, which means that knowing the difference between the orbital velocity and terminal velocity can let us determine how much the capsule is going to heat up, and therefore if it's going to burn up and explode and kill everyone inside and make everyone stay really sad. So, finding area is very, very important, and we're going to be learning about that today. Now, we have used integrals to find area before, but we've used them to find the area underneath the curve. But it's been a little while, so for our opening exercise, we're going to review that. Sound good? Okay. So let's say that I have the curve y equals x to the x squared plus 2. Let's actually make it f of x. And I want to know what is the area underneath the curve in the interval. Give me two numbers.
3
and
4.
4. In the interval from 3 to 4. Okay, so I'll go ahead and do this one together with you, and then I'll give you another one just like it as practice. Okay. So let's go ahead and draw the situation really quick. What is this line x squared plus 2 going to look like? What's the x squared draw? What shape is this? It's a parabola. Is this going to be a parabola that's open down, or a parabola that's open upward? And what does this plus 2 have to do to it? It's going to shift it how? Up, down, left, or right? To the right, you think? It's going to be up. Think of it this way. Whatever number I plug in here, say 2 squared plus 2, this is just going to increase whatever this value is by 2. So it's going to cause the whole thing to shift up by 2. Okay? So let's go ahead and draw the situation. Okay, 1, 2, 3, 4. So we need to find this area in here, correct? From 3 to 4. So how are we going to find that area? What mathematical tool lets us find the area underneath the curve? A calculator can do it for us, but I don't want to use a calculator. I want to do it by hand because I'm cool. And calculators are stupid and I'm smart, so don't want to trust the calculator. What method can we use to find the area underneath the curve? Anyone remember this one? A dead silence falls over the room. The area underneath the curve is given by the integral over that curve. The definite integral specifically. So, the area between a curve and the x-axis is given by the integral of that function from a to b dx. So the area between a curve and the x-axis, I should specify the interval. In the interval a b is given by. Okay, make sense? So let's go ahead and solve this problem using an integral. So, what are our bounds of integration going to be for this problem? 3 and 4. We're going from 3 to 4. So what number is going to be down here? And up here? Awesome. Okay, what function are we taking the integral of?
X squared plus 2.
Okay, let's take the integral. What's the integral of x squared, y'all? X to the third over 3 plus a 2x. Okay. Oh, and what are our bounds?
4, 3,
4 and 3. So which one are we going to plug in first?
4.
The 4. This is going to be 4 to the third power over 3 plus a 2 times 4. And then what are we going to do with the lower part here? We're going to subtract it. And what are we plugging in this time? 3. Don't forget about these parentheses. Without the parentheses, you'll be missing a negative sign somewhere, and it will make your answer come out wrong. Okay. So, what's 4 to the third power? That's going to be 64 over 3. Can we divide 64 and 3?
No.
Nah. Plus 8 minus, what's 3 to the third power? Divided by 3 is 9 plus 2 times 3. Okay. What's 9 plus 6? That's 15. And 8 minus 15? See, 15 minus 8 is 1, 2, 3, 4, 5, 6, 7, 8, 7. So it should be a negative 7. So now we have 64 thirds minus 7. How can I add these two fractions together right now? Yeah, we can subtract 21 thirds. And what's 64 minus 21? 43. So 43 thirds. Or alternately, once you get to here, you can just plug the whole mess into a calculator, but you have to be really careful with parentheses. Okay, so there we go. We found the area of the shape under this curve. Okay? Does it make sense how we set it up? And did it make sense how we did the integral, the definite integral? Okay, I see some pencils waggling, and we'll give you about 30 seconds to get the rest of this copied down. Okay, so you think you can handle something like this on your own? I'll be gentle.
P goes on top.
Okay, so I want you to find the area under the curve. Let's say the integral from, let's keep things pretty simple, let's say 2 to 3, of four x to the third power plus x. Now let's lose the x, just keep it like this. Dx. Okay, fair enough? So, find the area underneath this curve. I'm going to take attendance. I'll give you guys, let's say, 3 minutes. I'm sneezing. Attendance. Hannah's here. Elsie's here. Karen's here. Joe's here. Is there Nervina here? Let's see. Okay. Have you not answered?
Oh, yeah.
Yes. So you should get 4. You should get x to the 4th of 4x to the 4th over 4. Force cancel. So you get 3 to the 4th minus 2 to the 4th. Excuse me. See, you guys got an answer?
Mm-hmm.
So let's go to. So we're plugging in first 3 to 4, right?
Oh. Is it such a?
Is that what Blue's it?
Awesome. Okay. So this was pretty straightforward, and everyone got it right. So the integral from 2 to 3 of 4x to the 3rd power dx. So do the reverse power rule. What's our integral going to be? X to the 4th power, added 1 to get x to the 4th, divide by 4. I know it's backwards, my bad. So we end up with x to the 4th over 4x to the 4th over 4. 4's cancel. We're plugging in first in 3 and then 2. So we have x, or 3 to the 4th power minus 3 squared. Oh, 3 to the, 3 to the 4th. I'm sorry. 2 to the 4th. Okay, what's 3 to the 4th power, y'all? Since apparently I can't do math today.
81
Minus
16
is
65.
cool. So we found the area underneath this curve. Okay, so let's go ahead and take a look up here. Okay. Now let's try a situation that's a little bit different. Okay. So what if let's see, do I have internet today? Go. We actually have internet. Okay, that's awesome. Okay, so let's try a different problem. Let's say that we need to find the area in between, let's say, what does the book want us to do? Let's say that we want to find the area in between y equals secant squared of x minus, or let's see, find the area in between n y equals sine x on the interval that goes from 0 to pi over 4. So let's go ahead and graph this situation and see what we can see if we can figure it out. So we have y equals secant squared of x. That's this guy. And we have our beloved and familiar sine wave. And what are the intervals that we're working with here? 0 to pi over 4. So we're starting from x equals 0, so x equals 0. And we're going up to x equals 4. Or not 4, x equals pi over 4. Okay, so that leaves us with, there we go. So if we want to find the area of this this funky shape sandwiched between these two functions. So we want to find the area in there. Any ideas for how we're going to do this? How are we going to find this area? Okay. Say what?
Find the integral of both.
Okay, so we have one function. We can find the integral and find the, let's see, a different color here. We can find the integral underneath the secant. And we can also find the integral underneath the cosine. Then we can just subtract it. Fair enough. So let's go ahead and write that down as a problem. So the area in between them, that's going to be the area, what's our interval here? So we're going from where to where? 0 to pi over 4. Okay, so what's our first function? Secant squared of x dx And then you think we can just subtract them, find the area underneath the tall one and subtract the lower area. We should be good. Okay. So what's the lower integral? What are our bounds?
0.
I fell asleep.
You fell asleep during lunch?
Yeah, I took got to take a 10-minute nap. Yeah.
That's why you said the alarm clock.
I
It's
was too sleepy.
We live and we learn. Okay, minus the sine of x dx. I was wondering where you were, because I know you weren't going on the senior trip. So, well, you're here. That's important. So from our rules of integrals, is there anything that we can do to maybe make this less awful? Because this is like two integrals, and for each one we have an upper bound and a lower bound.
Derivative tables, integral tables.
Integral tables will help us, but what was that, Tamara?
Combine it.
Yeah, let's go ahead and combine them into one integral. So,
Oh yeah, it's an integral rule.
yeah, we're allowed to, in the same way that we're allowed to split up a sum, we can combine them if it becomes more convenient. And we can combine these because they have the same bounds. So that leaves us with secant squared of x minus sine of x dx. Okay. Okay, well, let's do it. What's the integral of secant squared? Anyone remember this one? It is tangent.
Oh.
Okay. So don't be afraid to look up an integral table in your book. So the integral of secant squared is tangent. And what's the integral of sine?
Cosine.
Cosine. So the
Wait, yeah, it is cosine.
but except that there's this negative sign here. What's the integral of negative sine?
It's cosine.
A positive or negative?
Positive.
A positive. Okay, remember, so just thinking about this in a circle, it goes sine to cosine to negative sine to negative cosine and back to sine, right? So that's for derivatives. For integrals, you have to go backwards. So here we're starting from a negative sign, and we're going backwards to a positive cosine. Make sense?
Yeah.
Okay. And what's our upper bound?
Pi over 4.
Pi over 4. What's our lower bound? 0. Okay, let's do the math.
I did.
What is tan? Okay, so what are we plugging in first? The pi over 4 or the 0?
Pi over 4.
We're plugging in the top number first, pi over 4. And what are we subtracting?
Subtract or add?
Well, we plugged in the upper bound here.
Okay.
Yeah, but now we're plugging in the lower bound.
Tan 0, which is 0
Tan of 0
plus 1.
cosine 0. Okay.
0 plus
Am I
1.
good?
Yeah.
I'm not good. I made a mistake.
Plus 1. C.
Plus C is only for indefinite integrals. But when we don't have a bound, I missed something else.
Parentheses.
We're doing the top, plugging in the top minus plugging in the bottom, right? Except that's not what I'm doing here because I'm just subtracting this. I need to be subtracting that whole thing. Okay, make sense? Okay, let's do it. So, tan of pi over 4. What is tan of pi over 4? Let's look at a unit circle. Go away. Okay, so tan of pi over 4. Tan is sine over cosine, right? Y over x. So it's going to be root 2 over 2 divided by root 2 over 2, which is anything divided by itself is always 1. Okay, so that's 1 plus. What is cosine of pi over 4? Uh-oh, have we not used the unit circle?
Cosine pi over 4. Looks like it's Well, it's square root 2 over 2.
Do we need a quick refresher?
Yeah.
Yeah, I mean, usually just use a calculator. I wouldn't mind that. But yeah, let's go ahead and do a quick refresher. This will complete it. It's pretty easy. So
Why
sine.
is you have to memorize like a whole bunch of different things there?
As long as you have the unit circle, you don't really need to memorize much. So it's pretty simple. So the angle here, that's our input into our cosine. That's our theta. And these points here are our outputs. That's the answer to plugging something in. Now, the first number, is this an x or a y? The second number is an x or a y. Okay, well, cosine of theta will equal the x coordinate. And sine of theta, I should say this is of theta. Sine of theta is equal to, that looks like an alpha, x. And sine of theta is equal to the y coordinate. Fair enough? And what is tangent? Tangent is y over the x. Fair enough? So what is, just looking at this, what is sine of 2 pi over 3?
2 pi over 3. The sine value is square root of 3 over 2.
So it's a sine, so we care about the y. The y is square root of 3 over 2. Okay? Make sense? Not quite? Not quite there yet? Okay. I'm gonna put up a problem. I'm gonna ask you guys, I'm gonna put up a simple use of the unit circle thing. I'm gonna put cosine of an angle. I'm gonna want you to find it, and I'm gonna want you to write it down without saying it. Okay? And then you're all gonna hold up your work to me so I can see what each of you did. Okay? This is gonna just take a moment, but it's useful to know. What is cosine of, let's say, 5 pi over 4? Just write down on paper and write down the markers. What's cosine 5 pi over 4? Using a calculator? Use your unit circle.
Use the unit circle, is it right there?
Yep, it sure is.
Oh, maybe it's square root
Does cosine care about the x or the y?
two. Oh, I was looking on the right side.
Okay, does cosine care about the x value or the y value? The x. That's right. Pi over 4, do we care about the x or the y? And what number is there pi over 4? This one, anything. It's in there. Okay. That's all right. Everybody needs a refresher sometimes. Okay. So anyway, so from our unit circle, what is cosine of pi over 4?
Maybe it's square root of 2 over 2. Yeah.
Okay. And what is, okay, so now we're subtracting, what's tan of 0? So here we are, what's our y value? What's our x value? And what's 0 over 1? 0. And what is cosine of 0? minus that. Oh, let's see, distribute that in. Minus a 1. Does anything cancel out here? Leaving us with root 2 over 2. Okay? So, with that, we found the area. Internet, don't do this to me. There we go. So with that, we found the area between those two functions. Okay. So does this make sense? So what we did was we realized that if we do the area of the top one and subtract the area of the bottom one, that'll tell us the area of the desired shape. Then we use our integral rules to combine them into one, which makes things a little bit easier to handle in this case. Because that way we didn't have to do the indefinite integral top minus bottom thing for each equation. It would just be more work that is necessary. Okay. So, do you think you can handle one of these on your own?
Sure.
Okay.
I don't understand.
So, I'm going to put up a problem. Where are my flashcards? My instructional coach wants me to use a new technique with you guys. So what I'm going to do is I'm going to pass around these flashcards and you're going to do it on these. Yep, you are being watched. Big Brother is watching. Okay.
That's what you call your. That's what they say. That's how they call professors in PCC.
Okay. So I'm going to hand out a flashcard and you're going to work it out on these. Okay? Then when I'm done, I'm going to examine them and I'm going to choose my favorite wrong answer and I'm going to talk about it. But it's going to be all anonymous, so I'm not going to tell anyone. Not going to tell it shit. I'm not going to air anyone's dirty laundry. Okay. So let's go ahead and find the area between, let's say, let's go ahead and find the area between y equals, yeah, that'll do. Let's find the area in between y equals, yes. Let's make it the area in between y equals 2x and y equals, let's say, 6x to the 5th power, and we're going to be finding the area on the interval from 0 to 2. Fair enough? So to help you get started, I'm going to pass out the flashcards that I want you to do your work on. I'm going to help you visualize it by graphing it up there on the TV.
How do we know which one to put first?
The good news is that you don't have to worry too much about which one to put first, because if you get them the other way around, you'll just get a negative answer. Small minus a big instead of big minus a small.
Oh.
So if you put a negative answer down, it's not going to end up being that big a deal. Actually, better idea. Oh no, that's all. I'm going to actually make a quick change to that. I first realized I made a mistake. Okay, so y equals 2x, and y equals 6x to the 5th power. Isn't that interesting? Actually, I'm going to change our interval a little bit. We're going to go from 1 to 2 is what I'm looking at. From 1 to 2. Okay.
Oops.
This is being a problem child. Which is doubly embarrassing because I'm being observed. Okay. So we're finding the area of this. We're finding the area of this very long, very skinny, almost knife-shaped region in between 6x to the 5th power and 2x. Okay. Now, finding the actual area between these would be a pain in the butt. But with integrals, we can do it pretty easily. So, remember, it's going to be the top one minus the bottom one. By the integral, go ahead, we'll combine into one integral. And there. Okay, where's your top one?
Do I have to solve it on?
Yes. That way I can see everybody's work. Good. We're done.
Thinks.
I am actually recording, right? I am. Awesome. It would have been super awkward if I was not actually recording. What you got?
That's completely correct.
Potentially.
So even if we got a negative number,
Don't worry. If you get a negative number, don't worry about it too much. We'll talk about why that happens. Why that might happen.
Put your son. There's a part of the state.
yes, Maruga.
I don't think I got number.
Like the face is all red. Is that
Is
what?
Or am I think I'm just always this red.
Yeah, it's like. Yeah, man. That you're maybe just
Maybe.
yeah.
You can see it.
Yeah, that's right.
Man.
Sorry.
Okay. Interesting.
Okay.
Well, I have some good news and I have some bad news. The good news is this is going to be really interesting to talk about because no two people got the same answer.
Oh, wait, I messed up.
Okay, so
Did anyone get the right answer?
well, so if we're looking at our graph, in this region here, what's higher up? The red line or the blue line?
Blue line.
The blue line. The blue line surpasses the red line right there. So the blue is our 6x to the 5th. So that's the thing we should do first, right? Okay, so
That's why it's.
okay. So to look at so let's go ahead and look at interesting. A number of them were close, but not quite there. Okay. So we're taking the integral from 0 to 2 of the top function, 6x to the 5th, dx. Oh, from 1 to 2, rather. 2x dx. Okay, so what's the integral of 6x to the 5th? It'd be 6x to the 6th over 6, which would give us 6x to the 6th over 6. What's that going to give us? That's just going to give us x to the 6th power. Minus, okay then, what's the integral? This is going to give us 2x squared over 2, which will just cancel out to 2x.
No.
Sorry,
X
squared. There we
go.
Okay, so what are we plugging in first? 2, so we have 2 to the 6th power minus 2 squared, 2 to the 6th power, minus 2 squared. Then we're going to subtract the lower limit,
1,
which is 1 to the 6th power, minus 1 squared. Okay, so 2 to the 6th power, what is 2 times 2 times 2 times 2 times 2 times 2? Well, that's 4 times 4 times 4. That's 16 times 4, which is 64. Minus, what's 2?
4.
That's 4. Okay, so then we can distribute this minus sign. What's 1 to the 6th power?
1.
So we have a minus 1. And what's 1 squared?
1.
And a 1, these two negatives will cancel out and give us a 1. Negative 1 plus 1 is?
0.
64 minus 4 is 60. Okay, so in our answers, okay, so in our answers, so I'm going to take a moment, I'm going to choose my favorite of these. So this one is right, which means it's boring. Let's see, this one, the person put in their, for this one, the person did the 2x and then subtracted the 6x to the 5th. So did everything right, and at the end they got a negative answer. That's fine. If you get a negative answer, it's not too difficult to... If it was me and you weren't sure which one to do on top, I just do the problem anyway, and if I get a negative answer, I just erase the minus sign, because that would be the only difference. You know, the top minus the bottom will give me the same magnitude as the bottom minus the top. See what I'm saying? For the same reason why 2 minus 3 will give us the same number as 3 minus 2. They're just going to have a different sign. So that one was not too
So
big.
you got right. I should ask.
Oh, that way.
This is interesting. So I'm going to write down what this person did, which is very interesting to me. So they got their integral. They got their integral set up. They put the 2x first, but that's not too big a deal. I'm going to put down exactly what they have here. Okay, so it's not a huge deal, but there is already a mistake that's been made. What do we see here? What's missing? We need the dx's. But that's not a huge deal. So they combine the 2 into 1. The integral from 1 to 2 of 2x minus 6x to the 5th and they again forgot the dx, but we'll go ahead and put that in. And then they took the integral, and this is where things got interesting. So when they took the integral, this is what they put down. What happened here? What did they do? First of all, what did they do right?
X to the 6.
So 6x to the 5th power, they did perfectly. And for the record, I have no idea who these are attached to. So. And what did they do for the 2x?
They just wiped away the x.
They took the derivative instead of the integral. So it's important to keep our derivative and integral rules straight in our heads. Okay, this is kind of a fun little activity. Talking about my favorite wrong answers. It's fun. It's fun. Okay, so let's go ahead and try this again. I'm going to put up another problem similar to this one. Ouch. Let's see how much time is left on this recording. 5 minutes. Okay. So I'm going to put up another problem. This time we're not going to do the flashcard thing. We're just going to work through this one together. Okay, so we need to find the area between, let's choose some interesting functions. Ooh. I know. And for this one, you're going to need a calculator to actually evaluate the answer. Oh wait, no, not integral. So let's say 1 over x. Okay, and let's make our upper function. You don't want me to do my words. Okay, let's say square root of x. Let's do this on the interval. Let's do this on the same interval from 1 to 2. So we're going to find the area of this.
Not working. We see where it's right now.
Just zoom. Okay, so this time we're finding the area of this freaky little sliver right in here. This little kind of chocolate chip looking area. So we're finding the area in between 1 over x and y equals the square root of x. You might need to use a calculator to actually compute out your numbers. Okay. So first of all, which of these is on top? Which of these is higher in that interval?
The blue one.
So, Gerard, which one is going to be which of the two functions are we going to put down first? In other words, which one is higher up? The square root of x or the 1 over x?
Square root of x.
Okay. So go ahead and find this area. Find the area between these two right here. Okay? No flashcards for this one. Just go ahead and do it in your notes. Probably get your notes down.
You're recording?
I am recording.
Is that right now?
Good question. Let me check. It is not. There's still about 5 more minutes.
should stop it while we're working and then.
So how are we going to take the integral of the square root? What are we going to rewrite it as? X to the 1/2 power. So rewrite your square root as x to the 1/2 power. And what was the integral of 1 over x?
I thought it was.
Natural law.
Natural log. That's where you're going to need a calculator.
Are we using those same,
Same bounds, yeah, 1 to 2.
Right. 1 over x is rewritten as natural log of x.
It's integral is natural log of x.
Oh.
We just have to, it's the x, the square root of x that we're going to have to rewrite. There, found my language. Let's see. So you rewrote it as x to the 1/2, but that's not actually the integral. So when we rewrite it more like over here. So x the square root of x is x to the 1/2, and then we have to. No, that's really weird. We're going to add 1 and then divide it. So what's 1/2? 3 over 2. And then we're going to divide by 3 x's. But when we divide by a fraction, we flip it. So move it at the top. 2x over 3. Okay, about 1 minute left on this recording, so I'm going to stop and then immediately restart it again. I am not looking at the camera.